Okay, so video 2 for 14.1, part B, net ionic equations. So we first need to talk about what is a formula equation. So a formula equation is what you are used to seeing in Chem 1 and Chem 2 so far. So a formula equation is an equation that uses neutral formulas or symbols for all the reactants and all the products, like I said, what you are used to seeing in sciences so far. So something like this. We have HCl plus KOH yields KCl plus H2O. The only thing that may be a little bit new to you is I've added in states of matter. So I've got an aqueous solution of hydrochloric acid, an aqueous solution of potassium hydroxide, yielding an aqueous solution of potassium chloride, and then liquid water. So that's going to be important to this part of the chapter. So you need to make sure that you are understanding what that means and also putting it in the equation. So we just abbreviate S for solid, L for liquid, G for gas, and then AQ for aqueous. Okay, an ionic equation, you sort of know how to do this, you just haven't written them yet. Basically, it's an equation that separates all of the neutral formulas into the ions that they would form in solution, specifically an aqueous solution. So it looks something like this. So I've taken HCl and I've split it apart into H plus and Cl minus, the ions they form. And now I've also split the potassium hydroxide into its ions, so K positive, OH minus. And on the product side, I've split potassium chloride into its ions, and then water stays water because it doesn't do anything when it's in itself. So you have to take a formula equation and get it to the ionic equation. Then you can get to a net ionic equation. But you first have to know what are spectator ions. So spectator ions are ions, charged particles, that do not take part in a chemical reaction, and therefore they are found both before and after the reaction has happened. So they are found on both the product and the reactant side. So think of a spectator of a sporting event. They're sitting there just watching. They're not partaking. That's exactly what this is. So I've taken that ionic equation, exact same thing, and now I've highlighted what ions are the exact same on both sides. So here's my arrow. To the left I have my reactants, and to the right I have my products as ions. So H plus is only on the reactant side. No H plus on this side. Chlorine minus, however, is on both sides. So I've highlighted it. That's a spectator ion. It's on both sides of the reaction because it didn't take place in the reaction. And then I also have a potassium ion on both sides. And then I have my hydroxide ion only found on the reactant side, and then my water is only found on the product side. So I've highlighted the spectator ions in yellow. I suggest doing the same, some type of highlighting or marking so they stand out to you. It's going to make the next step easier. So finally, we get to our net ionic equation. So a net ionic equation is an equation that only shows the ions that actually partake in the reaction, specifically the neutralization reaction. Basically, you have removed the spectator ions. So what I've highlighted in yellow is going to disappear for the net ionic equation, and the only thing that's going to be shown is what's in white. So my net ionic equation, going backwards, so I started with this equation. I broke it into its ions. I highlighted or marked the spectator ions. I am now left with just H plus aqueous, OH minus aqueous, yielding liquid water. That is a net ionic equation. We got rid of the spectator ions, and this is what's left. Okay, so it's not a hard process. You just have to know how to break things apart and then know very clearly what the spectator ions are so you can get rid of them appropriately. So in all of these examples, I have broken it down for you, but you need to know how to actually write the net ionic equation. There's a couple rules you have to follow. So obviously you're going to first take the formula equation given to you and write the ionic equation. That means you have to look at the charges from your periodic table and assign them to each ion appropriately. So you're going to separate the aqueous compounds into ions. So if you see AQ, you must separate into ions with charges. You're going to leave the solids and the liquids as compounds. You do not separate them. And you'll also leave any aqueous acids, which will also be labeled together. So the only thing you're separating is something that has AQ. You next, once you write the ionic equation, figure out what the spectator ions are, and then you cancel them from both sides, and then you're left with the net ionic. So the hardest part is just step one. So let's do an example. I actually already wrote the ionic equation for you. So baby steps to start. So this is already separated for you. That's why it looks like there's so many plus signs, because they're all separate. So your goal is to now figure out where are the spectator ions and write the net ionic equation. So pause the video, try that. Okay, so I've highlighted, so the exact same equation as up here. Now I've just highlighted the spectator ions. So NO3 minus and then NH4 plus is found on both sides. This should not be italicized. It just is the way it is, have no meaning. So you then cancel those out, and what's left in white is your net ionic equation. So like I said, if you want to just cross these out lightly or highlight them, you're getting rid of them. Highlighting is not good in this case. So my net ionic equation is then just CD2 plus S2 minus yields CdS, cadmium sulfide solid. And notice up here, cadmium sulfide was a solid. I did not separate it into ions. You only separate the aqueous things. Okay, let's try another. Write the ionic and the net ionic equation. So this should look familiar to you. So try to repeat what we just saw. So everything that's aqueous must be separated into ions with the appropriate charges. Water is a liquid, so it's left alone. Did you get something looking like this? So HCl split into H positive, Cl minus. KOH split apart into K plus and OH minus. KCl split apart into K plus and Cl minus. And then water was left over. I also highlighted the spectator ions, so chlorine ion and potassium ion. So what would a net ionic equation be? So you should just have H plus, OH minus on your reactant sides, and then water as a liquid on your product side. Hardest part is doing the ionic equation from the formula. If you do the ionic equation right, and you identify the spectator ions appropriately, you should have no problems with the actual net ionic equation. Okay, let's try another. Write the ionic and the net ionic equation for this formula equation. So notice I have an aqueous acid. You're going to leave that whole, but the other aqueous, just aqueous, gets broken apart into ions with the appropriate charges. And you're just kind of looking at the radical or the element itself. Ignore the extra subscripts. You know that comes from balancing charges. And then water is a liquid, so it stays whole. Okay, so my ionic equation should look like this. Barium has a +2 charge in group 2. Hydroxide and nitrite both have a -1. Okay, so I've highlighted my spectator ion. I only have one in this case. So I'm going to have on my reactant side 2 things and my product side 2 things. Okay, try another. Remember, you can always pause the video if I'm moving too quickly. Write the ionic and the net ionic equation for this. Once again, aqueous acid and a liquid stay untouched. So pause the video, write the ionic equation with the spectator ions labeled, and then write the net ionic equation. All right, hopefully you got this for your ionic equation. My potassium is my spectator. For my net ionic equation, I am left with HF and OH minus on the reactant side, and on my product side, F minus and H2O. Obviously, this is not balanced. It's not a formula equation, so we're not worrying about the law of conservation of matter or balancing because that is not the concept. Okay, let's go a little bit harder. So now I'm giving you a word equation, so throwing you back to Chem 1. Write the formula equation from the word equation first, then write the ionic and the net ionic. So this is where you have to remember how to write your formulas. And I will say I forgot to put the Roman numeral 2 in for zinc, but zinc only has one charge on your periodic table. So here is my formula equation, and I'll show you how I got this. Okay, so I have zinc Zn, and like I said, I didn't put the Roman numeral in here, but it is a +2. Nitrate -1, so that's why I got this 2 on the outside. Aqueous environment. Ammonium, NH4, is a +1. Sulfide is sulfur, that's a -2. I crossed them, that's why I got that. Aqueous environment. Yields zinc. Once again, a +2. Sulfide a -2, so no subscripts there. Solid. And then ammonium again, +1, and nitrate -1. No subscripts there. If you wanted to, you could throw parentheses. Now do your ionic and net ionic equations. So hopefully you got this for your ionic equation. So zinc has a +2 charge. Nitrate has a -1 charge. Ammonium has a -1 charge. Sulfur has a -2 charge. Zinc sulfide stays whole because it's a solid. And once again, ammonium +1, nitrate -1. I've also highlighted my spectator ions. So that means I should have a net ionic equation of this. This is as complicated as it can get. Okay, now try this one. Once again, formula equation, and then ionic and net ionic. Pause the video, try it out. Okay, so kind of looking at this, we know that hydrogen is H, and it's got a +1 charge. Chlorine, Cl, is a -1 charge. Calcium, Ca, has a +2 charge. Hydroxide, OH, is a -1 charge. And once again, calcium, chloride, hydrogen, oxygen. Whoops. So I'm just showing you where this information is coming from. This is coming from your periodic table. So I didn't write the charges correctly because I'm not writing them in the actual formula yet. So hopefully your formula equation looks like this. So HCl, no subscripts, aqueous. Calcium hydroxide, you had to add the subscript 2 outside the hydroxide ion. Radical, also aqueous. Yields calcium chloride with a subscript from crossing charges, aqueous. And then hydrogen oxide is water from crossing the charges, and it's a liquid. Okay, now you're basically doing what you just did. So it's kind of going forwards and jumping back again. Now break it apart into ions. So here is my ionic equation. H+, Cl-, calcium 2+, OH-. And notice, in the actual ionic equation, you have to write 2+, not +2. And that is a superscript phrased up. And then yields calcium 2+, aqueous, Cl- aqueous, and liquid water. Spectator ions are highlighted. My final answer, my net ionic equation, is just H+ plus OH-, aqueous environment of both yields liquid water. So as I said, this is as complicated as it can get, giving you a word equation, first having you write the formula equation, breaking apart into ions, and then the net ionic equation. As I said, it gets kind of working forwards and backwards again because you put them together and then you separate them, but it's just showing that you understand the full aspect of the difference between a formula equation and an ionic equation, and then moving to the net ionic equation, do you understand the concept of spectator ions, and then what the net ionic equation should look like. So that is officially the end of 14.1.